Yeah, Juan Ontiveros, the University of Texas at Austin. Well, my role for the University of Texas is to, I'm in charge of the utility systems for the whole campus. So really in that role is to try and anticipate the changes in the campus. And the campus has been undergoing a lot of growth over the last 10 years. So our challenge is to keep up with the utilities. Because we're forced to be self-producing, and the utility cannot support our full load, it's an extra pressure on our organization to make sure we keep up with that growth. We've added 10 million square feet in the last 10 years, and there's another million square feet in the works. So that's the challenge with the campus is to keep up with the growth in the campus and to master plan it properly. That's really what my other kind of role related to that is, because there's so many interrelated systems. The way we produce our electricity and steam and cooling, it's all an interrelated energy system. So you have to master plan that properly. Otherwise, you may have a shortcoming in one area that causes problems. Well, I think the utility operation, the challenge with the utility operation is, and most people that work in universities, is that everybody's competing for the same money, and so you have the challenge on one side of saying, I've got to expand my plant to keep up with the growth, and you have to do this in a way where it can cost the university the least. So you try and develop projects that meet the long-term growth of meeting the challenge of energy production, but do it in a way that's cost-effective. So there's kind of a balance there. So you have to, can you do that? Can you sell the project? Can you finance it? Can you structure it so that it provides you enough savings to offset the cost? And so that's the real challenge that we have. Yeah, well, we've been since I've arrived. Really, we've had to really restructure the whole organization, because it's not just putting equipment in, putting in systems. You have to transform how you do the work too. Your people have to shift their skill sets. And when I arrived, there was no digital controls. So we've really had to shift from being a mechanic and a valve turner, is kind of how I put it, to being more technicians. And they have to have a much broader knowledge of the overall system because the interface is all so much tighter. And so we've, the first part was really just to start learning, teaching them about how digital controls and systems work. And then as we've had to modernize all of our electrical system with a new substation, all new switchgear. That was the start of really everything. Then we had to add, for us, because we self-produce everything, firm capacity is very, very important to us because we have a very high reliability standard. Part of my arriving, they had only had one outage of power in 35 years. So that's a very tough standard to keep up with. And if you don't have firm capacity, you're a big risk. And the way we operate, while we're connected to the grid, we operate as an island. In other words, we consider ourselves at risk anytime we're connected to that, we're relying on the grid because we're more reliable. And so the challenge is, when you have as large a campus, we serve 16.7 million square feet with just our system. The total campus is like almost 20 million square feet. When we serve such a large area, it's so much research area, they cannot sustain any outages. So the challenge with adding steam turbine, adding chillers, upgrading the whole substation, and then now we're in the process of adding more generation and more chillers. Doing that in a manner that you don't shut anything down. That is a major challenge. But fortunately, with our systems and with really careful planning and good managers, we've been able to do that. Well, it really has been really inspiring for us because when to see, we're fortunate that we're in a position where you get to see a project completed from concept to finished product. And there's not many places that you can do that with. And so when you go to all this effort and go through all the pain of that whole process, really, because it is a whole process you go through, to see that you can achieve, we improved our heat rate for electrical production by over 30%. And that's going to go even better with our new steam turbine. We were 12,600 BTUs per kW, and now average last year was 9,800, and with the new turbine, it's going to go around 8,000. So it's a very satisfying to see those kinds of results. So we've been able to each year, sure there have been years where we've had some peaks because we've had to operate in a non-efficient manner because we're replacing equipment. We don't have any choice. You got to run with what you have. But now that we're seeing the new efficient equipment come online, the new chilling station, the new turbine when it comes online, the new cold water storage tank, and the new steam turbines that we've added in our system, plus all the other fine-tuning things that we've done in the plant, we've been able to, we're projecting next year to go back to 1977 gas levels and fuel levels for the campus, and which is pretty phenomenal when you consider that the campus had 9 million square feet in 1977, and we serve 16.7 million square feet now. So that's very satisfying when you see that. You see those kind of results. When I started working at UT Austin, I really didn't know anything about the power plants. In fact, the first time I ever was in a power plant was my job interview. So when I came in the job and now I had to assume these responsibilities and really starting and seeing what the issues were, I needed to learn. And so I think it was just really by accident. I saw the article in a magazine about IDEA, and I said, well, that looks like a pretty good organization. So I came the first couple of times. I came because an attendee. I hadn't joined, but then I saw the kind of knowledge and the focus on energy that IDEA had, and at that I was in the point where I was really just trying to learn everything I possibly could from any position. And it really surprised me how collegiate it was. I'm used to being in the physical plant administration side of the business, and those organizations are very collegiate and very sharing and very open. And so I've been past president of associations before, like regional associations, and this organization reminded me of that collegiate environment. And I think sure initially, and it's they were very friendly. I'm an outsider. At UT Austin I was an outsider. Here I was an outsider, and I never felt uncomfortable in this organization. And so that's the other reason why, I think that it's got the potential for really being what it could be. I've always had a focus, and I've always believed that the way you get ahead is by being efficient, because if you're efficient, you use less fuel, you save money. And by being efficient, it means you also have to use more integrated systems to work. I've always believed in using technology. In any job that I've ever worked in, technology is the way you get things done. So I think that it's very fitting to focus on efficiency. My focus will be on efficiency for the future, because there's a lot of discussion about carbon tax and unfortunately most of that focus is on technologies that really haven't developed yet. They're still kind of in the laboratory, and still a lot of study has to be done, a lot of development has to be done, like sequestration and coal sequestration and things like this. And so I think that the United States, the nation, the world, can really benefit by focusing on efficiency. I think the Europeans have taught us that. You go into Denmark and you look at some of the things that they've done and the things that Europe has done in focusing on efficiency. That's where, and I think that's where we can get a short-term gain, or a gain for, I think, over the next 10 years. If you focus on efficiency, we've been able to produce twice the amount of energy for twice the amount of space with the same amount of fuel over a 10-year period. So if everybody could do that, and everybody can, and I'm not the only one. I mean, St. Paul, Minneapolis St. Paul has done the same thing. Anders Reidecker has done exactly the same thing. He's doubled his energy output with the same amount of fuel since 1983. And so this is not rocket science, and it's not, you're not waiting for a laboratory to develop an approach. These are all proven technologies, proven approaches that you can implement right now with people right in the IDA right now. I mean, it's why that's the part that excites me. I think that there's a tremendous amount of potential there. The problem is we have to educate our legislators, our leaders in cities and municipalities that they can do this. And unfortunately, when you deal with utilities and municipalities, unless you incentivize them in some negative way, that's just not going to happen. There have been too many years of focus on the monopoly, and so they've always had a profit guarantee. And so we need to find a way to incentivize them to do this, because I mean it really bothers me when the average efficiency for electrical production last year was 33%, the average for the nation. That it really sickens me. You know, when I'm considering that we're going to go next year, we're projecting to be a total efficiency of 90%. But if you just consider power, we're going to be at 56%. You know, that's 20% better than the average for the nation. And so I think that's the if we focus on that and do that, we could buy ourselves quite a bit of time, benefit the environment, so that these other technologies can develop if they ever develop.